Gotta turn it off, it's burning. Today we will do some further studies on the capacitive ion drive. This is basically just a cylindrical capacitor, one copper tube here, another copper tube here. The outside tube has plus 2000 volts charge coming around there. The inside tube has negative 2000 volts DC coming around here. And when we put argon gas into that tube from this supply here, the argon gas flows through the tube, between the tube outside and the tube inside. It just makes an arc until it approaches these magnets. And when it enters the field of these ring magnets, basically like a stack of ring magnets, it starts spinning. Then when it gets inside the field, it spins and ejects very strongly, providing thrust off to the left. Very explosively. Originally I tried 5 microwave oven transformers at 11,000 volts, but didn't help. If we come out at 2200 volts here, 240 volts in from one transformer, that gives you more current and it'll still ionize the argon gas. And you see you get 2 AC wires, red and black, coming up here. We go through a rectifier, full wave rectifier, AC in, DC out, and this is rated for 6 kV, 3 amp. We have DC power go through the red and the black wires into the cylindrical capacitor, red outside, black inside, and it ionizes the argon gas all the way around. It makes an arc. Now that doesn't do anything until we put that arc inside of these ring magnets, and then it spins and ejects quite strongly. Let's watch to see how that works. Turn on 2000 volts of DC power across this cylindrical capacitor. You can hear the argon gas flowing, but there are no magnets. Currently they're over there. Turn it on, and we get about 1500 volts, and you can see an arc. It's not very exciting though, is it? It doesn't do anything. Just a blue arc of ionized argon gas. The argon ions are on the inside, and the electrons are on the outside. Next, when we add those magnets at some distance from the end of the cylindrical capacitor and turn on the power to 2000 volts, you can see the argon gas spinning. See, it's just spinning. Finally, when we put that cylindrical capacitor with argon up inside of the cylindrical magnets and turn up to about 2000 volts, it spins. And also ejects quite strongly. No magnet. Magnet. No magnet. Magnet. It is essentially a rocket exhaust with lots of heat and lots of argon gas being shot out by the heat pressure. Here you can see that plastic tube, which I used as an exhaust, has been burned completely. The copper electrode's been burnt. There's ashes everywhere. So this is less than 1 kilowatt. When we go to 10 kilowatt, it should be a very powerful rocket engine. Construction of this device is very simple. We just have two tubes of copper, one inside the other. One of these tubes is plus 2000 volts, that red wire coming out of a full wave rectifier over there. The other tube is minus 2000 volts, which is this black wire hooked up here, also coming out of that full wave rectifier over there. So when we turn on argon gas from a supply, the argon gas comes to this tube, goes between the two copper tubes, and ionizes. Next, when we add magnets to it, specifically a stack of ring magnets, essentially, neodymium magnets, those magnets at first from a distance will make the arc spin by the North Pole going through the magnets, and then when we put the magnets over the cylinder itself, they'll spin, but also they'll eject by another Lorentz force, because these magnets here have axial magnetic fields that also point inward. The one field here and the other magnetic fields that way. And secondly, the capacitor itself will then eject all of its electrical energy as induced by the magnets, and all of the electrical energy which was stored in the capacitor will shoot the argon gas outward, will recombine and go out as rocket thrust. Let's look at it one more time now. We've got the front of the cylindrical capacitor just near the back of the magnet. You can hear the argon gas hissing through slowly. We're going to turn on the power to about 2000 volts from the variac. It'll ionize at about 1500 volts. It's 250. Without magnets, it just spins. Put in the field. Inside, it'll start ejecting. Got to turn it off, it's burning. The argon gas from this supply first gets ionized by the 2000 volts DC across these two tubes, a cylindrical capacitor, and then the special kind of magnets, a stack of ring magnets, make it spin and shoot out. The power to the capacitor comes from these two wires, which attaches to a full wave rectifier. I'm using 6 kilovolt rated 3 amps, and then we have AC power coming into the rectifier from this one microwave oven transformer. That's really the best, with a 240 volt input. And you have to put some plastic over the microwave oven transformer, because if you touch it, it's live, it electrocutes you. You always have to give it a plastic shield. And to control the amount of current going into that microwave oven transformer, we put a 60 microfarad run capacitor. The bigger the capacitor, the more current, and a little 1 ohm resistor here. And the input to that is just a 1000 volt variac to control the voltage, and a 1000 watt isolation transformer. So the power comes out of that white isolation transformer into the variac. We control the voltage with that knob. The current's limited at 240 volts by this run capacitor, 60 microfarad. That goes into the front end of this microwave oven transformer, which costs $30. Those two wires comes out the black end, that little wire, at 2200 volts. The AC current goes into these yellow wires here through this 6 kilovolt rated full wave rectifier, and that gives you 2 kilovolt DC through the red wire and the black wire, and that's what goes into this two copper tubes, a cylindrical capacitor. Very, very simple. Positive outside takes the electrons, and negative inside. It makes an arc, and then we add these magnets around it, and we add argon gas from supply. The argon gas first gets ionized, argon inside, electrons outside, then it spins and shoots out very strongly. At 1 kilowatt, it's very powerful. At 10 kilowatt, it would be a good rocket engine. DC current at 6,000 volts is hot enough to melt copper using the ionized air. The negative electrode's always the one that burns. That's because the heavy nitrogen and oxygen atoms are hitting it, and electrons only hit the positive electrode. What we're seeing here with argon gas is called blow-by instability. The arc is quite long and doesn't progress in just one section, but it goes in one part, not the other. So that doesn't give us really much acceleration of the arc as a whole through the tube.